Okay, this is number 11a on the Are You Ready for Calculus, and we want to solve this equation. 3 sine squared of x equals cosine squared of x, and we want to solve that on the domain. X is between 0 and less than 2 pi, or less than or equal to 0. I'm sorry, x is greater than or equal to 0 and less than 2 pi. So we can divide both sides by the cosine squared as long as the cosine of x is not equal to 0. So we have to make that kind of stipulation. So we divide both sides by the cosine squared of x, and then we divide both sides by 3, and the one over here becomes 1/3. And this makes sense because if we take the sine squared over the cosine squared, we get the tangent squared. And remember the tangent, when we're doing these solutions, we have to be careful about, situations like restrictions on the domain. And remember the tangent, if you look at the tangent curve, I kind of drew it over here so you can see it. Remember the tangent is asymptotic to pi over 2 and negative pi over 2, but it doesn't exist at those points. It's undefined. That's basically because we have like a 0 in the denominator, because the cosine of pi over 2 and negative pi over 2 is 0. So what's going to happen is we have to put these restrictions on here, so hopefully we won't get that as a solution. So if we kind of solve this, the tangent squared of x equals 1/3. Well, if I take the square root of both sides, square root of tangent squared is just tangent, so that equals plus or minus the square root of 1, which is 1 over the square root of 3. And then we remember on our unit circle, the solutions there would be pi over 6. And now we have plus or minus, so when it's plus 1 over the square root of 3, it'd be pi over 6 and third quadrant, 7 pi over 6. And then when it's negative, it would be 5 pi over 6, which is the second quadrant, and the fourth quadrant, which is 11 pi over 6. So those are your 4 solutions between 0 and 2 pi. So that wasn't too bad. You have to use unit circle. So you have all 4 quadrants are taken into consideration. The positive takes 2 quadrants in, first and third, and the negative takes in 2 and 4. Okay? The next one, move it over here. This was the B part. Now the domain here was between negative pi and pi, greater than negative pi and less than pi. So that was the domain. And we had this equation, cosine squared minus sine squared equals the sine of x. This is not too bad because we don't have any fractions we can deal with. We can just subtract the sine of x from both sides here. First of all, I'm going to get everything in terms of sine x, because that's kind of, it looks like I'm going to try to get a trinomial. So I'll try to get everything in terms of sine x first. So the cosine is the same. Cosine squared, remember, is 1 minus the sine squared. So we make this substitution. Everything else stays the same. And then I can simplify this. So this is 1 minus 2 sine squared of x equals the sine of x. So we can see that all right. Okay. And then if I subtract the sine x from both sides, or actually I added the 2 sine squared of x, and I subtracted 1, and kept that positive. And notice I've got a trinomial here in sine x. It's like 2x squared plus x minus 1. So we can factor that. So if you want, you could write down 2x squared plus x minus 1, and we would factor this. And this ends up factoring to be 2x minus 1, x plus 1, if you factor that. Except in this case, my x is the sine of x. So it's a trinomial in the sine of x. Remember, if we factored this, 2x, x, the only way we could get it would be a 1, and the sine of large is positive, so that'd be positive 1 and negative 1. So we factor this trinomial, 2x squared plus x minus 1 would be factored to be 2x minus 1, x plus 1. So this is the same thing, except 2 sine squared of x plus sine x minus 1, same thing. And then we set each of these factors equal to 0. And then if I add 1 to both sides and divide by 2, I get the sine of x equals 1/2. And if I subtract 1, I get negative 1. So we only really have to worry about actually we're going from negative pi to pi. So we should be okay in this case. So the sine of x equals 1/2. That's positive, so it's going to be positive in the first and the second quadrants. And the sine is 1/2 when pi over 6, when x equals pi over 6. And then it'd be 5 pi over 6 for the second quadrant. Remember, all students take calculus, so the sine is positive in the first and the second quadrant. So those are the solutions for the sine of x equals 1/2. All right? The sine of pi over 6 is 1/2. The sine of 5 pi over 6 is 1/2. And then in this case, sine of x plus 1 equals 0. Sine of x equals -1. And in this domain, the only time that the sine of x is equal to -1 is when x is equal to negative pi over 2. So that'd be right over here in this range. All right? Now I checked these both, and you could go through and put both these values in, all three values in, and check your answers, and they all check out. Okay, so this is what this is down here. Actually check these. Okay, let's take a look at the last one. Letter C. Let me cover this up so you can see there's a lot of writing here going on. This is letter C, and then we're trying to solve this. And this is my equation. Tangent plus a secant equals 2 cosine of x. Now again, we're always looking for places where this is undefined. Now again, we know the tangent is undefined for x over 2 and for pi over 2 and negative pi over 2. So we can put this restriction and say pi over 2 plus k pi, where k is any integer, positive or negative, and that's going to give me, keep adding the pi over 2, I'll get, or keep adding pi's to this, I can get 3 pi over 2, 5 pi over 2, etc. And these are the places where this tangent is undefined. And if I put negative, that'd be negative pi over 2, negative 3 pi over 2, etc. Okay? And the same thing with the secant. The secant is the same thing as 1 over the cosine. So whenever the cosine is 0, the secant will be undefined. So I have to put that restriction also. And the cosine's equal to 0 multiples of pi over 2 and negative pi over 2. That's when the cosine is 0. So those are restrictions on our domain. And what I did was keeping those restrictions in consideration. And remember, the parameters of this problem, we wanted to solve for all the solutions between negative infinity and infinity. All right, all these solutions. So it's all values, so we have to realize that this thing keeps revolving around. What I did was I put everything in terms of sine and cosine to try to kind of solve the equation. It's normally what we do. And then multiply everything by cosine. Now I can do that because the cosine will not be 0. It can't be 0, otherwise it's undefined anyway. So, and then this gives me the sine of x plus 1 equals 2 cosine squared. Then like before, we try to get it into a trinomial. So cosine is the same thing, cosine squared is the same thing as 1 minus the sine squared of x. And then I can multiply this out. And then regroup my terms on the left. So I've got 2 sine squared of x plus sine of x minus 1. And this was like the last problem. Same thing. Okay, 2 sine squared of x minus 1, sine of x plus 1, if we looked at the b part. And then we just set each of those factors is equal to 0. And these were my possibilities. Now again, we had the sine of x equal to 1/2. We had either pi over 6 or 5 pi over 6. But since my domain are all real numbers, I have to add 2k pi, because every 360 degrees it rotates around and gives me another coterminal angle, which is another answer. So we have to add the 2k pi, where k is any integer. So I'd be adding plus 2 or subtracting 2 pi, plus 2 pi or minus 2 pi, plus 4 pi, minus 4 pi, etc. And I would keep regenerating answers. And the same thing with the other part, 5 pi over 6, plus 2k pi. K is any integer, so we don't have to worry about plus or minus. Okay. Now, the sine of x equals -1, okay, well that gave me negative pi over 2, but that's not a solution because we had a tangent in this problem. Remember back in letter B, we didn't have a tangent in the problem, so that was no problem, no issue. So we could have x equal to negative pi over 2. But in this particular problem, C, we have a tangent occurring, tangent of x, and tangent of x is undefined for pi over 2. So this solution doesn't enter into our situation. Okay, so we can't have it. We don't have the solution here because the negative pi over 2 won't work, or the pi over 2 won't work because it's undefined for tangent, so we cross that out. So these are my only solutions right here. And I check these out over here. You can kind of take a look at the check if you want when they check out. So that's number 11. A little more complicated.